Hey there, science fans! Today we're diving into the fascinating world of data science to explore a powerful tool called linear regression. Now don't let the fancy name intimidate you. Linear regression is simply a way to find the relationship between two things that can be measured. Imagine you have a bunch of dots scattered on a graph. Linear regression helps you draw a straight line that best fits those dots, revealing the hidden pattern. This line isn't just any random line though, it's a special line that helps us make predictions about future data points based on the patterns we've observed. Pretty neat, right? So, why should we care about drawing lines through dots? Well, my friends, linear regression is like a magic lens that helps us uncover hidden relationships and make sense of the world around us. It's a fundamental tool in data science because it allows us to predict future outcomes. By understanding the relationship between variables, we can make educated guesses about what might happen next. Identify trends. Linear regression helps us spot patterns and trends in data that might not be immediately obvious. Make informed decisions. Businesses and researchers use linear regression to make smarter decisions based on data-driven insights. From predicting stock prices to understanding customer behavior, linear regression is everywhere. Now let's peek under the hood and see how linear regression actually works. Remember that straight line we talked about? That line is defined by an equation, often written as y equals mx plus b. Don't worry, it's not as complicated as it looks. Y is what we're trying to predict, our dependent variable. X is the variable we're using to make the prediction, our independent variable. M is the slope of the line, telling us how steep it is. B is the y-intercept, showing us where the line crosses the y-axis. Linear regression finds the values of m and b that create the line that best fits our data points. This best fit means that the line is as close as possible to all the points, minimizing the distance between them. Let's say we want to see if there's a relationship between the number of hours a student studies and their exam scores. We collect data from several students and plot it on a graph. Using linear regression, we can draw a line through these points. This line would tell us things like for every extra hour studied, a student's score tends to increase by X points. Now, if a new student tells us they studied for a certain number of hours, we can use our line to predict their likely exam score. Section 5. Real-world applications of linear regression. Linear regression isn't just for classrooms and textbooks, it's a real-world superhero. Here are just a few examples. Healthcare predicting patient recovery times, based on factors like age and pre-existing conditions. Finance forecasting stock prices based on historical market data and economic indicators. Marketing, understanding the relationship between advertising spending and sales revenue. Sports, predicting a team's chances of winning based on player statistics and past performance. The possibilities are truly endless. Section 6. Advantages of using linear regression. Why is linear regression such a popular tool? Here are some reasons. Easy to understand and implement. Compared to other machine learning algorithms, linear regression is relatively straightforward. Interpretable results. The results of linear regression are easy to interpret, allowing us to understand the relationship between variables clearly. Computationally efficient. It can handle large data sets and complex calculations without breaking a sweat. These advantages make linear regression a go-to technique for many data analysis tasks. Section 7. Limitations of linear regression. Of course, no tool is perfect, and linear regression has its limitations, sensitive to outliers. Extreme values in the data can significantly influence the line of best fit, assumes a linear relationship. It may not accurately model relationships that are non-linear, prone to overfitting. If we're not careful, our model might become too tailored to our specific data set and not generalize well to new data. It's important to be aware of these limitations and use linear regression appropriately. Section 8. Conclusion. Linear regression's enduring value. So there you have it. Linear regression is a powerful and versatile tool that helps us unlock the secrets hidden within data. From predicting the future to making informed decisions, it plays a vital role in countless fields. While it has limitations, understanding these helps us use it effectively and appreciate its enduring value in the ever-evolving world of data science. Section 9. Keep exploring the world of data science. This is just the tip of the data science iceberg. I encourage you to keep exploring, keep asking questions, and keep discovering the amazing ways data can help us understand and shape our world. Remember, science rules.